Number 3, there are many square prisms with a volume of 150 cubic inches. Let W represent the side length of the square base and H represent the height in inches. This means that the formula for the volume of these prisms are right here, and then we also have a formula for surface area. Basically, we're going to do this problem the same way we did the cylinder problem in lesson 16, as well as the cylinder problem that was on the CYU. The only difference is now this is a square prism instead of a cylinder, but we're going to do it the same way. So starting with A, which I will do up here, okay, write an equation for H in terms of W when the volume of the prism is 150 cubic inches. Show your work. So our formula for volume is V equals W squared times H. Okay. And we're going to substitute in 150 for V, since that's the volume. Substitute that in for V, and now we're going to solve for H, meaning we want to get H by itself. So we want to rewrite it so that I have H equals something. So to do that, I need to get rid of whatever's on the same side as the H. In this case, I have to get rid of the W squared. Since it's being multiplied, I get rid of multiplication by the opposite, which is division. So I'm going to divide both sides by W squared. Okay. Dividing the right-hand side by W squared will make that go away, leaving H by itself. So I end up with H equals 150 divided by W squared. Okay, so that is our answer for part A. Part B, using your solution from part A, what is write an equation for S as a function of W when the volume of the prism is 150 cubic inches. Show your work. So now we're going to go to the surface area formula. So 2W squared plus 4WH. And just like I did in the CYU and in lesson 16, I'm simply going to take this and I'm going to substitute or plug in that expression for H. Okay, so that will give me 2W squared plus 4 times W times H, where I'm going to replace H with 150 over W squared. Exactly the answer that I used in or figured out in part A. After that, it's just a matter of simplification. So the 2W squared, this first term right here, won't change. Okay, there's no simplification to do there. But here in the second part, I can do some simplifying. So just like I did when it was a cylinder, I can extend the fractional divider. Okay, and I can deal with the W's that is in the numerator with the W's that are in the denominator. So in the denominator, I have W squared. So to remember, W squared really means W times W. So there are two W's in the denominator. So what's going to happen is the W in the numerator is going to cancel out one of the two W's that are in the denominator, leaving me with one W in the denominator. So let me recap what I just said. The W squared in the denominator is W times W, two W's. The W that's up in the numerator will cancel out one of the two that's down here, leaving me with 1W in the denominator. In the numerator, it leaves me with 4 times 150. So 4 times 150 is going to be 600. If I put that all together, I end up with 2W squared plus 600 over W. You will do something very similar with this exact same formula on the test. It'll just be a different volume. So that was B. Part C, what is the surface area of a rectangular prism with a volume of 150 cubic inches and a width of 10 inches? So we can now use our simplified formula for B. So 2W squared plus 600 over W. I can now plug in W equals 10 inches. The width is 10 inches. So this will be 2 times W squared. So this will be 2 times 10 squared plus 600 divided by W. So I just need to calculate 2 times 10 squared plus 600 over 10. So again, we're not going to make it harder than it is. We're all about efficiency. So I'm just going to put this in Desmos to get my final answer. So 2 times 10 squared plus 600 divided by 10. So our surface area and our answer for part C is 260. So just to recap with this one, I used my answer for part A to help me with part B, and then I used my answer from part B to help me find the answer to part C.